Hi everyone, welcome to today's lesson on multiple mole conversions. And so in the previous lesson we learned about moles and how moles can be used to convert between grams and moles, volumes of gas and moles, as well as atoms and molecules to moles. And so today we're going to be focusing on doing multiple conversions using multiple conversion factors. This is similar to what we've done before, except this time we're doing it in the realm of, or in the context of chemistry. And another type of problem asks us to find the number of atoms inside a given molecule or molecules. For example, how many atoms are there in 5 molecules of NaCl? Okay, so if I have one molecule of NaCl, let's see if I can find my pointer here. NaCl is one molecule, but inside NaCl, I actually have NaCl. Okay, so if I have, I'm looking for atoms here, atoms equal, if I have 5 molecules of NaCl, the easy math would be go, well, if I have 5 molecules and I have 2 atoms in every molecule, then it'd be 5 times 2. But to do this in the context of conversions, okay, in one NaCl, I have 2 atoms. And so you're able to cross off the kind of the molecules, so you get atoms left as the unit that you're looking for, and then now you go 5 times 2, well, that means I have 10 atoms. And so this type of problem kind of looks at molecules, and we go deeper into molecules by trying to figure out how many atoms we have in that molecule. Now, another way that these questions can be asked is not just any atoms, but maybe some specific atoms like hydrogen. So here we have we're asking how many hydrogen atoms are there in 30 molecules of H2O. Okay, so I'm looking for H atoms, hydrogen atoms, and my starting kind of value here is 30 molecules of H2O. Now, if I want to convert from the number of molecules to atoms, well, let's take a look at my water molecule here. In one molecule of water, H2O, I have 2 hydrogen atoms. I have a total of 3 atoms, but 2 of them are hydrogen and 1 of them is oxygen. So this question is more specific. It's not just asking how many atoms are there, it's asking for how many hydrogen atoms. So once I have this equation set up, molecules of H2O can get canceled out. 30 times 2, that means I have 60 hydrogen atoms. Our knowledge with the different conversion factors, we can perform multi-step conversions. Now these are just like the conversion problems we did back in the earlier lessons here. The key thing is to make sure we set these things up. Okay, so this is a nice summary chart that kind of tells you all the relationships that we looked at. There's 4 conversion factors that we're going to need. So going from moles to number of particles, moles mass, moles between volume, and then molecules and atoms. So as we keep practicing the questions as we do the fun sheet, this will become a lot more familiar with. All right, A, what is the volume occupied by 50 grams of NH3? So let's see what we're doing here. Okay, so we're trying to go from volume to mass. Now, we haven't learned any relationship that allows us to go from volume to grams or grams to volume. Okay, but just like how in a unit conversion kind of lesson there, even though we can't go directly from grams to volume, what we can do is have an intermediate kind of base unit. Okay, but in this case, we don't have a base unit, we have moles. So moles is kind of like the center of the flowchart where you convert from one unit to moles and then moles to a different unit. Okay, let's put that into action. What is the volume occupied? So I'm looking for volume. This is 50.0 grams of NH3. Okay, so let's take a look. right now I can't go from grams to volume, but I can go from grams to mole. So if I have that conversion factor, moles and grams, that is going to be using the molar mass of NH3. So this is going to be 14 plus 3, 17. So this is 17 grams per 1 mole, grams of NH3. Here we can cross multiply, or cross out. Now remember, I'm not happy at moles because that's not where I want to end up. I want to end up at volume. So I'm going to then convert from moles to volume. Volume, so this is going to be liters. Kind of had a brain freeze there. Okay, so 50 grams of NH3, we've converted that to moles. Now we need to go from moles to volume at SATP. So we know that at SATP I have 24.5 liters per 1 mole. And if I punch it in my calculator, 5 divided by 17 times 24.5, I get 7.21 liters, I should say, of NH3. Okay, so this multi-step, you'll notice before I go on, I'm just going to recap here. I start with 50 grams of NH3. I cannot convert that directly to volume, but I can convert it to moles. Once I get into moles, I can then convert out from moles into liters. When I do the math, I get 7.21. Actually, I don't think it should be 7.21. Let's see, 50 divided by 17 times 24.5. So 70, forgot a decimal place. This should be 72.1 liters. Let's try another one. What is the mass of 1 times 10 to the power of 12 atoms of chlorine? Okay, so I'm looking for mass. I have atoms, so 1.00 times 10 to the power of 12 atoms. Now, if you remember, we cannot go from atoms to mass directly. What we can do, though, is to go from atoms to mole, and then from mole to mass. Okay, so this means I can kind of cancel out this one, cancel out that one, leaving me with just mass. Now we just have to fill in our conversion factors. Okay, so moles and atoms, these are Avogadro's numbers, so it's a little bit too small, but I'll write it here. 6.02 times 10 to the power of 23 atoms per mole. And the last one here, this is kind of moles and mass. That's the molar mass. So chlorine, that's going to be, if I remember correctly, is it 35.5? Yes, it is. So this is going to be 35.5 instead of mass. I can now write grams per 1 mole. Okay, let's do the calculations. 1 times 10 to the power of 12 divided by 6.02 times 10 to the power of 23 times 35.5. Okay, so here we have a small number. This is going to be 5.90 times 10 to the power of negative 11 grams. Okay, so once again, you see we did kind of multiple conversions. All right, we have 2 more examples here, C and D. So how many oxygen atoms are contained in 75 liters of SO3? Okay, so we want oxygen atoms, so O atoms. Starting value, 75.0 liters. We can't go from liters to atoms, but we can go from liters to moles and moles to atoms. Okay, so I have 24.5 liters per 1 mole. Okay, I am now at moles. Moles from atoms. So at 1 mole, I have 6.02 times 10 to the power of 23. Let's do the math. And I get a giant number of 1.84 times 10 to the power of 23 atoms. Okay, now if we stop there, we might have been, oh, okay, I think I got it right. Using Avogadro's number. Okay, let's double check. Let's actually double check what we just did. So I took the 75.0 liters. Okay, I divided by the 24.5 liters, multiplied by the Avogadro's number, and I get an answer that I think is the oxygen atoms. Okay, but one thing I failed to neglect, or I didn't see, is the fact that when I use the Avogadro's number, I can't just choose that it's going to represent atoms. It represents molecules. It represents the SO3. And that's because in the beginning, that 75.0 liters, that's referring to the molecule of SO3. So if I use Avogadro's number, what I'm going to be representing is the number of SO3 molecules. And so reason why I always say make sure you write out the units is if you don't, then that's where you can get tricked. Okay, so this question is not right because we failed to show the units. Okay, so in addition to kind of losing marks for not showing units, we also got the wrong answer because we didn't write the units to help us remember. Okay, so oxygen atoms equals, I have 75.0 liters of SO3, okay? Make sure I make that distinction. And so once again, I cannot go from liters to atoms, but I can go from liters to moles. Okay, so this is particularly moles of SO3, 22.4 liters of SO3. Okay, these can cancel out. I have moles. Now I want to convert moles to atoms. So once again, moles of SO3, okay, this is going to be 6.02 times 10 to the power 23 molecules. It is molecules because this is representing SO3. That's a molecule. Okay, but since the question asked me for oxygen, well, if I have one molecule, how many oxygens do I have? Okay, so if I have one SO3, look at it, I have 4 elements in there, S, and 3 oxygen. So I can just multiply by 3 oxygen for every 1 molecule. Okay, so I'm running out of space, but if I did that, I would get 5 divided by 20. Oops, this should be 24.5. So divided by 24.5 times 6.02 times 10 to the power 23. Oop. I think my calculator just froze. All right, let's do that again. So 75 divided by 24.5 times 6.02 times 10 to the power 23. And then times 3. Okay, so I get a huge number. I have 5.53 times 10 to the power of 24 atoms of oxygen. All right, final example here. Aluminum oxide, Al2O3, has a density of 3.97 grams per milliliters. How many atoms of aluminum are in 100 millimeters of aluminum oxide? So let's take a look. I'm looking for atoms. Okay, am I looking for specific atoms? No, this is how many. Oh, yes, I am. I just want aluminum atoms. Okay, so let's see. I have 100 mils. So 100 mils is the same thing as 0.100 liters. Okay, let's not make that same mistake. So I have Al2O3. Now I can't go from liters to atoms. What I can do is go from 24.5 liters to 1 mole. Okay, put in our units in. Oops, that's a little bit ugly. Now I can go from moles to atoms. So in 1 mole of Al2O3, I have 6.02 times 10 to the power 23 molecules. And once again, I need to multiply by 2. I have 2 Al for 1 molecule. Okay, when I do that, I get 0.1 divided by 24.5 times 6.02 times 10 to the power of 23 times 2. I get 2, oops. I get 4.91 times 10 to the power 21 atoms of aluminum. Okay, so it sounds really complicated. This lesson here, I mean, at first it seemed a little bit short, but it's actually a little bit long because of the amount of calculations you have to do. So please make sure you try the fun sheets. The fun sheets have a lot of practice, and once again, with a lot of practice, this becomes very mechanical. Okay, it becomes very simple, and you look at it, you know exactly what units to use, exactly kind of where to place the units. Okay, but that comes with practice, so please make sure you practice the fun sheets. All right, that's it from me. I'll catch you all next time.